Hi, this is Group 49. The focus of this project is to harvest tweets from across the cities of Australia on Nectar Research Cloud and undertake a variety of social media data analytics. In this project, we are making a 4 instance cluster environment and mining interesting geoinformation by summarizing tweets from 8 cities using Twitter Harvester and combining them with Orin dataset. All of this is being deployed using Ansible and Boto scripts. We will now further discuss the system architecture, Twitter Harvester, set of Orin data, CouchDB MapReduce, and system UI.
Alright, so in this video, we're going to explore the Boto scripts that are associated with launching the instances and attaching volumes to them. So the first thing we provide is the access and secret keys, which come as part of the EC2 API credentials, and we provide a default image ID over here, Ubuntu. We give a key pair called default cloud, which is distributed across the team for logging into the instances, and the default place is Melbourne NP. And so we set up a connection and we create the instances. While creating the instances, we use the connection run. From the connection we have used and the run instance coming as part of the Boto. We provide the security groups. So I have included two additional security groups. One of them is the DB show, that is 5934, and front end, that is the 5000 port. And so there are a couple of more functions such as get the instance IDs to check the status or whether they're waiting. And finally, we launch the instances and we attach the volumes to each one of these instances. Now, as part of this cloud PT, shall not be able to attach the instance. So I shall go ahead and launch one of the instance and let's see how it looks like. While this does, on the main cloud, we have 4 instances running, each of them taking each of them utilizing 60 GB of volume storage, that is 240 in total. And as you can see, each of these volumes is attached with with a volume ID. Alright, so while this let's see how the instance launch looks like. And so we can see that one instance is now on. And while the now the instance has reached the launch state. Now we should move on to the Ansible scripts. And so you also an additional point, the volume won't attach because this is the secondary cloud. Thank you. All right, so in this section, we are going to see some of the automation scripts that are involved in the cluster uh, automation in terms of launching the instances and the packages that are involved. So first off, we will simply go to the path and we will run the Ansible playbook YAML script, which internally looks for the host file, which is present in our etc Ansible host file. And it goes through each of these packages looking for whether they are already existing in the instance and tries to install them. So as we can see, we are first installing the Git, then Python 3, pip3, TweePy, CouchDB, TextBlob, NumPy, NLTK, sklearn, so on and so forth. So I'll just go through some of the code that is built over here. Um, we clone the Docker repo, and over here we try to get the CouchDB to be running on the containers. And so before that, we set up the NLTK words, and that'll help us in the sentiment analysis. We run the Docker container on the port on different ports based on their usage. So for the access of the database in terms of read and write, we are going to use the 5984, and it would be on our regular 172.17.0.2 IP address. As part of the launching of the Docker containers, we are including a hashed password. So this is basically admin, but in a hash term. And we go on forward with setting some of the CORS policy on CouchDB module for get, put sort of inputs. And we clone our clusters, we save them. Finally, and most importantly, we create a cluster of all of these instances, Docker containers that we have formed, and we group them together under my host. Right, so as you can see, there is the npm part going on. It adds the CORS to the CouchDB, clones the cluster, and there you go. So it's done. And the way how you know it's done is we can see the IP address and the play recap, and we see that the OK and change things are already done. So this was the part where I ran the Ansible. Thank you.
In this section, I will introduce how the data is collected and analyzed. Firstly, our interested granularity of data is on city level. Before harvesting tweets, we assume a group of tweets tweeted by same user are very likely come from the same city. Hence, in order to harvest sufficient large amount of tweets in front of the access restriction of Twitter API, we created a hybrid crawler leveraging both Stream API and Search API based on our previous assumption. When one tweet is captured by Stream API with filtering, the crawler will extract the user ID in the tweet and use Search API to query on the user timeline. This approach successfully harvests many tweets in a short period and also decreased the access time. Secondly, we designed an embedded tweet analyzer to perform sentiment analysis, topic tagging, hashtag extraction, and timestamp tagging. Now I will show how the crawler works. So when the crawler running, I will keep introducing the embedded analyzer. We labeled each tweets either positive or negative in sentiment analysis. We used an LTK Twitter sample and Sent140 Corpora as our sentiment analyzer training data. We designed a baseline in sentiment analysis for helping us to compare the performance of our classifier. The average F1 score of our classifier on an LTK Corpora is 98%, and on Sent140 Corpora is 66%. For topic tagging, we create different lists of glossaries for different related topics such as AFL, cricket, alcohol consumption, and we use these topics to tag tweets. Then we define our 4 timestamps for different periods in a day: morning, afternoon, evening, and midnight. We extract the tweeting time of each tweet to fit the 4 time slots and tag with a timestamp. We also extract all the hashtags in the tweet. At last, we use a unique Twitter ID as CouchDB document ID to save our processed data in order to prevent duplication.
So now we'll talk about Aurin. Aurin is Australian Urban Research Infrastructure Network portal. It provides statistical information about the number of features about the cities of Australia. It provides data city-wise, suburb-wise. It provides enormous data that we can use for research. For example, now we'll have a look at this data set. This data set contains the information such as number of married people and number of unmarried people according to the different cities of Australia. So we extracted this data set in a JSON format and wrote a parser in Python language to parse this data and populate it into the CouchDB as required by the project. So now we'll have a look at the CouchDB instance. So CouchDB contains the database called Aurin, which is used for storing Orin data. So this Orin data contains 8 records, one record each for one city in Australia that we are capturing. So if we'll have a look at this record, it will contains all the information about the particular city in Australia. Now we can have a look at the number of information that we have captured, like median income, median age, unmarried males, unmarried females. So this data, as we can see, is of city Melbourne. So this data along with Twitter data we are using for analyzing different scenarios about the lifestyle of the people in Australia.
Now we move on to demo. We developed a cloud-based solution on Nectar Cloud. The research cities include Australian Capital Territory, Adelaide, Brisbane, Melbourne, Hobart, Perth, Darwin, and Sydney. We have developed 4 scenarios. Scenario 1. This scenario compares people moods with different times of the day. Times of the day has been divided into 3 parts: morning, afternoon, and night. The graph shows us percentage of sad tweets is more in morning and decreases as the day progresses. Scenario 2. Here we are comparing gambling activities with percentage of sports tweet in cities. Map and chart clearly shows us that number of sport tweet does not correlate with the number of people involved in gambling. It is not necessary that the people involved in gambling are sport lovers from the conclusion. Scenario 3. This scenario compares weighted average of married people with sentiment score. From the map and chart, it is clearly observed that marriage is not a disaster. Observations contradict the belief that the happiness of the people is inversely proportional to the marital status. Scenario 4. Sports tweets, especially related to AFL, are compared with financial status of the people. As we observe, number of people tweeting are more from Melbourne while least are in Darwin. This can be because Darwin doesn't contain a AFL team. We can state that income in the city is not directly proportional to sports enthusiasts, and the map and chart based on this solution totally give us the correct solution. Thank you.
CouchDB is a document-oriented NoSQL database where the document is stored in key-value pairs. In our project, we have used MapReduce functionality. This is similar to views. In Map, we filter the data, and in Reduce, we summarize it. In most of our cases, we have used count to summarize our data. The views which we create are used by the front end to render the data. Let me show you with an example. We can see the scenario where we compare the gambling data and the sports data. The gambling data is taken from the Orin and the sports data from the Twitter. In our Twitter JSON, we have a label sports which captures all the AFL and cricket related tags. In map, we map the cities and this tags sports. In reduce, we take the count. As we can see for Melbourne, the sports tweets are 115. If we run this in the terminal, it shows 101 for AFL and 14 for cricket, which is 115. Similarly, for Sydney, the sports related tweets are 27. When we check this again in the terminal for Sydney, so we get 15 and 12. which is 27. So this way we capture all the sports count. We can further show this on Photon. So for Sydney, they show this has 27 documents. Thus similarly we can see the data for other Australian cities, and we can run this view on terminal to get the correct count, and similarly we can check this data in the Photon.